The next thing I want to show is I'm going to move this exit into this loop, and we're just going to work with one of these comments. I'm going to show you how we can start breaking up that text into a bunch of characters. Okay, and this is the first part of this natural language processing application. Okay, it's all well and good to store a bunch of these comments, as we can make a huge list out of a bunch of comments, but how do we start to understand some structure, meaning out of all of that text information? What I'm going to propose to do, and this is a very rudimentary language processing application. They basically get more and more complicated from here on out, and you can study a whole literature about natural language processing, how to derive meaning, parts of speech, everything else. That's all outside of what we're going to do. I'm going to propose something really simple and say we can read in all this text, and knowing the way the Chinese language works, concepts like words can exist as a combination of one or two or sometimes more characters. Okay, and we're going to use this idea to basically generate a list of every possible word by looking at every possible sequential combination of 1, 2, or 3 characters. Because what do we want, right? We want just ideas. And every idea could be represented as a word or a series of words. And we don't care whether everything we store is this idea, but by looking at the frequency and seeing which combinations of characters appear more and more together, those more important ones that are structures that have meaning will float to the top, okay? Because those will be used more and more. And what's cool about Python is this stuff it does great, okay? It really doesn't bat an eye at storing billions of characters and then telling you exactly how many times the most common combination occurred. So that's my proposal for the process. It's not the only way to do natural language processing. It just happens to be, when I thought about it, that seems to be the easiest one. Based on what I just said, the structure of doing that is actually quite simple. We can imagine a string, right, which will be like, say, 20 characters. We can run through that string and take larger and larger combinations of sequential characters. So we can run through the string and get the 20 individual ones, right? So if we have 20 characters, take one after the other. That will be 20 individual possible ideas. And then we're going to run through and take every combination of 2 sequential characters. So if we have 20, there's going to be 19 of those, right? Take the first 2, second and third and fourth, fourth and fifth. We can do the same thing for 3 character combinations, 4, 5, and so on, actually up to whatever we want. Okay? So the construct of that is pretty simple. Remember I moved this exit into this loop. I'm going to run this again to make sure I'm just getting what I want. Okay, so yeah, I'm just getting the one string, right? I'm just going to apply this logic now to just this one string. Okay, so the first thing I'm going to do is break this string into a list of characters. Okay, this is just a Python function. I'm going to call the string function. I have to translate each character to Unicode first. This is just the decoding process. Okay, so I have this function. I'm going to take the text. I'm going to decode it, okay, to convert it into the kind of numerical representation of all the characters. And then I'm going to feed it into this list function, which will take that string and create a list of characters. And we can see what this does just by printing it. I'll hit run. All right, so I have this string, which right now is in Chinese format. And this is my list L. And you can see here it's a list, right, separated by commas. These are all entries in the list. Each one of these represents one character, one Chinese character. When you use the Unicode, this is actually how the computer sees each character. Right? And the reason we decode this is because Python's actually going to look at that number when it decides which things exist in the list, right, or in the data file. So this is already fine if we're going to look at only one character combinations. And now we can put all these in a list and say which one appears more than anything else. What I want to do, though, is extend that list to look at combinations of more than one character. So I'm going to set a variable called character number. This will store a range of numbers of basically the number of combinations I'm looking at. So in this case, I'm going to go from looking at one character at a time to 2 characters. And here I can set this to whatever higher bound I want in terms of how many characters the combination is going to store. I'm going to start with 1 to 2, okay? Remember, range 1, 2 will just create a list that says 1, 2, okay? You can check that here. So this function will just literally, actually this one will just do 1. So I'm going to do 3. So remember, the range function will just return a sequence of numbers starting with this number up until this number. Okay? So range 1, 3 gives us 1 and 2. Okay? And then I'm going to go through each one of those numbers. I'm going to start with 1, and then in the next time go to 2, and so on and so forth. Okay, and then I have a subloop here, which will start at each position of our character list, right? And it'll iterate through all the characters. So if our character number here is 1, we're just looking at every single character in this list. This loop will iterate over every single character and then store that in a list. Right now it's kind of like seems redundant because we already have that list of characters. But when now this character number is 2, I'm looking at every combination of 2 characters, and I want to iterate over every one of those in the list. I subtract 1 minus the character number. And what this will do effectively is, in the first case where I have looking at 1 character at a time, I'm going to look at the length of the list, which is say 20, right? I'm going to look at every one of those 20 things. Characters 1 minus 1 is 0. Anything minus 0 is the same thing, right? We look at all 20 positions. Now in the second case where I'm looking at every combination of 2 characters, this is going to be 20. This is going to be 2 now. Minus 1 is 1. So now I'm going to look at the first 19. Okay? Because I actually only have 19 sequential combination of 2 things. I'm going to look at this one, these 2, then these 2, then these 2, then these 2, and the last one's going to be these 2, right? I'm not going to have the 20th one. So this is just a way that each time I'm incrementing the number of characters sets I'm looking at, I'm decreasing the iteration in the list by 1. And then I'm going to create a variable which actually composes my word. This is a bit abstract, but I'm going to look at every combination of characters as a potential word or a potential idea. Okay? In the first case, each character will be 1 word. In the second case, each combination of 2 characters will be 1 word. And here I'm going to use the join command. And this is a pretty useful function for working with strings. I can give it an empty string. And the join command will take in a list of characters or strings, and it will join them using this string. Okay? And here we're going to pass in our array of characters. The first is going to be 1, and it's going to be a combination of 2 and 3 and 4 characters. And here I want to use my list of characters here, L. And from there, I will extract a subset of characters, starting with J, okay, as I'm looping through all these characters. And then here's the colon syntax. It defines a range in our list. And I'm going to pass J plus our char variable. Okay? So when there's 1, this will be 1 to 2, 2 to 3, 3 to 4, 4 to 5. When I'm looking at a combination of 2, it'll be 1 to 3, 2 to 4, 3 to 5, and so on and so forth. So after I generate this, remember I'm just looking at combinations of 1 and 2 characters, and I'm getting all of these words here. I'm going to put all of those words into a list of words. Okay, this will be kind of a big bag where all of the comments will be broken down into all these words, and they'll all be put into one list. So I'm going to specify a variable for this list in the very beginning of my script. I'm going to call it list of words target. Okay, I'm going to set an empty array. This will be a list of all my potential words from the target locations. This will be my OCT locations. Okay, remember here I'm only looking at locations that are in the OCT. And then every time I get a word, I'm going to append it to my list of words target array. Right? So all we're doing is very conceptual, saying any idea in Chinese might be some combination of from 1 to 5 characters. And we're going to have Python store all of them and then tell us which ones occur more often. So this double quote is just an empty string. That's the joiner. So when we have a list of these 3 characters, we're going to join them all together with nothing in between. So I'm still going to exit out after my first entry. Right? So I'm just going to stay with this comment. I've broken it up into a list here. I'm going to get rid of that print statement. And now I'm just going to print my list of words target list. This will be the current state of, after I process each combination of 1 and 2 characters, what that big bag of words is. With the idea that as we run through all the comments in every place, this is going to get bigger and bigger and bigger. I'm just going to run this at this point so we can visualize that list. Okay, so there it is. Here's the string. It was all converted to Unicode, and now I have this list. I have each character by itself, and at some point I have 2 characters here, right? So now I have, if this was 20, I would have 20 single characters, 19 combination of 2. And now I can use this range to specify how many possible combinations of characters I'm interested in. So maybe I would only want to look at combinations of 1, 2, 3, and 4 characters. Okay, so I'm going to say 5 is the upper bound of this range. I'll run this again. Okay, there it is. So now I have up to 4. You can see how this list has grown substantially. Okay, and the last thing I'm going to do is, in addition to generating this big bag of words, I also want to store the original string, because I'm going to use this to generate my features later. Okay, I want to keep some association between the words that I'm storing and the original string that it came from. Okay, so I'm going to create another array, and this is going to be my text list target. The list of words target will have my big bag of potential words, and text list will just have a list of all of my strings, right? So right here I'm breaking them down. But I also want to store the original string, so then later I can go back and count the number of times that these words I discover occur in the actual text, okay, per comment. So here I have this text, right? This is my comment. I'm going to store my actual text of the comment in this list. And I just want to decode that back into Chinese. So as I run through these, I'll have a list of words and I'll have a list of comments. At this point, this code will do exactly that. It will run through the whole zip file. It will look at just the entries in OCT. It will take all the comments within the year. It will break them all up into this giant bag of word combinations. It will store them in this list of words target. Okay, so there is our code. By the way, this structure, I've been using it. This is just keeping track of the files as we're scanning the zip file. This will give us a printout of the percentage of the zip file we have gone through. It's pretty useful. So I'm going to run this. So now it's processing the zip file. You can see because it's only doing stuff at those particular 36 locations, it's actually able to go through that zip file very quickly. Okay? As you develop, if you want to test more locations, like a whole neighborhood or a whole part of a city, this will take much longer.